Hi, this is lesson 16 continued. And what we're going to do here is, remember, we just found the 5-number summary. That's right here. And we found the mean for our student who had one unfortunate 0 as a test score. So what we're going to do next is, let's remove the 0 from the data. And we're going to recalculate. So we'll do our recalculations in orange. So let's do this. This is we're going to find it. Let's write it this way. We'll find the mean and 5-number summary when 0 is removed. Okay, so here we go. Let's take a look at what this happens now. So notice that I can just reuse these calculations from up above, except for now this 0 isn't here, and the number of data in my data set is now 7. So if I do that, then I'm still going to come up with x bar equals 128, because the 0 didn't affect the sum. But now I'm going to divide that by 7. And if we take 128 and we divide it by 7 and we round correctly, remember, we round it correctly, we come up with 18.2. And remember, since the data is in whole numbers, we round to the nearest tenth. Now, let's find the 5-number summary. So we have a minimum, a Q1, a Q2, Q3, and lastly we have a maximum. So I'm going to bring down my dot plot from above without the 0. So let's come back up here. I'm going to grab my cutting tool, and all of this the lower half of my picture doesn't help us. We just want this upper half here. So we're going to bring that, I'm going to copy that, bring that down here, we can use that, paste, and that looks, we'll make it a little bit bigger. There. Now, what we want to do is, first thing is, let's get rid of some of that line. I can put another line back in, so we'll do that. There we go. Now we can take a look at what we've got. And let's get rid of some of these. Oh, whoops, we didn't want that dot gone. We just wanted these little dots. Now, let's take a look at what we've got. Here's what we have. There we go. Now I feel better. Let's go back to our orange. Notice now we know the maximum is still 20. That one's easy to see. Our minimum is 17. And since we have 7 values, that means that the 4th value, counting from either the top or the bottom, that would be our Q2. So if we do that, we'll start here. 1, 2, 3, 4. And so that, I'm thinking it's going to be that 18. Let's try it again. We'll go 1, 2, 3. Now remember, we're going now the other direction, so 4, and there it is again, so Q2 is 18. I'll put a little box around that. Then, notice now I have 3 values in my lower bit, so let's try another color to keep track. So that means I'm looking at these 3 dots here for my lower 50%, and so you can means that they're, to divide it 3 evenly, the middle value, that would be the second, and so right here, that is Q1, which is 17. And if you do the same process up above, looks like you'll find that Q3 is 19. Now wait a minute, look at what happened. So notice from Q1, Q2, Q3, and the max, it's 17, 18, 19, 20. And look at what we had above, 17, 18, 19, and 20. Only the minimum changed. Only the minimum changed. But look at what happened to the mean. Let's take a look at the mean. So here we go. Notice that if I was that student and I got a score of, oh, and we're going to assume that 20 is a perfect score. So if I got, my average was 16 out of 20, well, that's 80%. In other words, that's a B. That may not be as good. That's not as good for a student if we got an 18.2. Well, let's see how that changes it. And we divided that by 20. Well, 18.2, let's see. That's going to give me a score of 91. Look at what happens just from doing that. Now we get a score of 91%. Well, that is an A. So, in other words, does that 0 dramatically affect the data? Well, in this case, if you were the student, I would argue that it does dramatically affect your grade. So we would call 0 an outlier. Maybe that day the student's car broke down on the way to take the test, or some strange thing happened and that for some reason they couldn't take the test and they were even prepared to take the test. But from all their other performances, that student did quite well. So we're going to now try to formally do this. But before we do this, notice this. The mean was affected. We're going to use dramatically, carefully, but that's what we'll call it. It was affected. Oops, the mean was affected. Sorry. The mean was dramatically affected. Let's try that. Was dramatically affected by the 0. However, the 5-number summary, it didn't change hardly at all. The 5-number summary hardly changed. And we say such a statistic. Such a statistic is called robust, meaning that little idiosyncrasies don't affect it. So the 5-number summary is a robust statistic. And let's do this now. Here's how we actually calculate to formally find an outlier. So let's do this. Our general rule is upper outliers are any values that are greater than Q3 plus 1.5 times the inner quartile range. Lower outliers are any values that are below Q1 minus 1.5 times the IQR. Okay, so, and remember the IQR equals Q3 minus Q1. So here we go. Let's try this now for our actual data set. So go back to our blue, and I'm going to start with my IQR because I actually need that one first. So if we look back up above, our Q3 was 19. Here we have it. Or we'll use it for the main set. or for the original data set, our Q3 was 19 and Q1 was 17. So we come down here, so we're going to go 19 minus 17, so that's 2. Okay, then our upper outliers are anything above Q3. Well, that's 19 plus 1.5 times 2. Well, that's going to give us a 19 plus a 3. So any value above 22 would be considered an upper outlier. In this case, there are no values above 22, so there are no upper outliers. Then let's check for lower outliers. These are values below Q1, which is 17, and then we subtract 1.5 times the IQR of 2. Well, this becomes 17 minus 3, but that's 14. So any value below 14 is considered a lower outlier. And we do have a value lower than 14, that's the 0. So we say the value of 0 is a lower outlier. So what you'll find as you work these problems is that some data sets have no outliers, some have both upper and lower outliers, some have lower outliers, and some have only upper outliers. It just depends on the data set, and you, as the statistician, just need to be willing to adapt and see what each data set has to tell. I hope that helps. Thanks for watching.